All right, UFC 346001, 16 August 2010. Unified Facility Criteria: Designing petroleum fuel facilities. The U.S. Department of Defense, United States of America. Approved for public leased and distributed and unlimited. Chapter 9 Piping Systems. 9.1 Introduction. This chapter provides guidance for the design of the new piping portion of the fuel system as discussed in other chapters of the UFC. This criteria provided with is intended to be generally the scope except where specific criteria is necessary to given situations. 9.2 General Requirements. Chapter 2 The General Design Information contains important information on fueling facilities. Does not start the design of any of the fueling system without first becoming completely familiar with Chapter 2 of the UFC. Of this USC. 921, Designing Requirements. Ensuring the piping design, material fabrication, assembly, erection, inspection, pressure test of the fuel piping system are in accordance with the NSI, ASME, B313, C Chapter 6 for the UFC, Design Requirements in Terminal Installation Pipelines, fully appropriate guidelines, specification, piping design, and material selection using the following design criteria for the piping system, unless otherwise specified with the service at headquarters. Provide underground piping in and around the area subject to the aircraft ground movements if approved with the service headquarters. Install the piping in concrete trenches. Um, when the trenches are employed to comply with the NFPA 415, the use of common trenches for more than one utility is prohibited. The fueling equipment for the may above ground where it does not interfere with the aircraft with the surface on vehicle movements. Design all clearance in accordance with the UFC 326002 standards design AW782428. In other cases, the above ground piping is preferable where it is not aesthetically objectionable or not exposed with the accidental damage, vandalism, blast, or damage or sabotage. Preferable method of routing the above ground piping out of the dike and area over the top of the dike over and avoiding creating the inverted view of the section side of the pump to avoid an air trap. Provide high point vents and low point drains are required preferable to facility plate 019. Hydrostatically testing new pipe system in accordance with the NSA ASME B313 during the testing disconnecting system components for the storage tank of the equipment which were not designed for the piping testing pressure protected against the damage of overall pressure of the hydrostatically testing system of to 1.5 the maximum allowable design pressure of the NSA ASME B165. The piping system flanges at 100 degrees Fahrenheit. See the table 9.1. Testing hydrant direction aircraft fueling system installation fuel pipelines with the fuel with the be used with the pipeline or the minimum fuel with the same. Minimum specification flash point is the fuel that will be used when the piping is in service. The temperature of the fuel and the ambient temperature shall be at least 20 degrees Fahrenheit below its flash point during the testing. Testing the water requires service headquarters approval where the water is authorized hydrostatic testing for the fueling of the pipe. Ensure that all the water is removed from the piping by either pigging or the piping, air drying the line, or vacuum extraction. Lay out piping between the piers and the storage tank of the cross country with the pipelines between the bulk storage and operation tank with the accumulated piping pigging operations using a long radius elbows, full port with valve with the bare tees to provision with the use for the connection of temporary launchers and receivers refer to the UFC 326001 design guidance that gives special consideration of smart pigging for the single wall pipelines. When laying out pipeline for the single wall aircraft, the hydrant system that considers smart picking and picking the design for the system with the required piping slope with the high and low level drains. Provide long radius turns, provide spool pieces for the terminal pig launchers and receivers. Ensure the valve is accessible for the removal and replacement of the spool pieces where it must be economical practical to lay the hydrant piping flat with the slope less than 0.2% provided with the capability of the rapid cleaning lines with a pig or two launchers per smart pig. This includes provided with long radius turns at the full port, valves, bare tees, and pig launchers into the receiver. Provide the thermal relief devices on install with the double block and the lead valves, other valves in the piping system. Provide the drain out of the non-freeze valve to all low points of the pipeline. Refer to the co-ops UFC 3130 series of construction above ground and underground piping in Arctic and subarctic conditions. 9211 hydraulic design in general is provided with the hydraulic design with the velocity of 7 to 12 feet per second on the pump discharge 3 to 5 feet per section on pump suction as full flow with the project specification conditions make it advisable to access these values. Consult the appropriate service headquarters. Consult the appropriate service headquarters with outlet pressure requirements design and suction piping to ensure that the net positive suction head required by the pumps is available under all conditions of the operation. Consider the following factors in selecting pipe size or operating requirements for the facility to preserve the capital cost of the pipe, capital cost of the pumping station, attending these facilities, operating cost of the system, harmful effects of the effective excessive velocity of flowing, including hydraulic shock of the static generation, fatigue of the failure causing silical loading. 922 piping arrangement. When possible, arranging the pipe in parallel grooves to facilitate multiple use of the support to minimize the amount of the trenching of the underground piping, to minimize the number of steps and styles needed across the pipe runs for underground and application consistent. Consider constructing when determining the amount of amount of space between the pipes using the following criteria. Provided looping pipe systems whenever practicable. Loops add to the flexibility reliable of the system when contributing to the product cleanliness, making circulation possible. Can be used with reducing the magnitude of the hydraulic shock. Sectional loops by the double block and lead valves to provide verifiable isolation to facilitate pressure for the testing between the main install of the cross connection for the flexibility operation auxiliary means for the continuous operation of emergency situations. Additional permit the use of the line blinds with a space limitation, particularly the use of the removable pig section of the fittings. Provided with a separate piping system for each of the grade of the fuel to be handled. Do not provide cross sections between grades. Four short runs provided line slope of at least 0.2%. 4 long runs make line slope sufficient to establish a positive drainage by the gravity, but without excessive bearing the depth. Make gradients uniform by between the high and low points. Trap all undesirables because they provide a place for the water and sediment to accumulate. They install the drains at the low point to allow the removal of any water for the condensation. These low point drains also provide with the capability to remove the fuel for the line maintenance. If slope is not possible, design the system to accommodate the pigging provided with the flanging connection for the pig launchers and receivers, long curvature fittings, bare tees, and full port valves. Install the high point vents for the remove the trapped air. Low point drains and are not required in inter-terminal pipelines. As a general rule of thumb, provide the space between piping with the aluminum minimum clearance of 3 inches between the adjacent flames. In certain situations, such as a piping trench or other restrictive location, it may be necessary to reduce the spacing. A minimum of 12 inches of one pipe diameter, whichever is greater, should be still maintained between the pipe walls. 923 Surge Analysis. Conducting a complete surge analysis with the system operation using the computer simulation and program. All systems quick and closing valves of the aircraft hydrant and direct the fueling system with more than 2 outlets, giving the full consideration for the cause effect of the hydraulic shock. It is especially important that the cause of the fuel system, such as an aircraft fueling system in which where the receiving tanks or the dispensing equipment may be damaged by the shock pressure, reduce the possibility of shocking, limiting the flow velocity. Avoiding the use of the quick opening and closing valves except for the required for the system operating with such a hydrant pit and valves do not reduce the flow of the velocity between the minimum velocity indicated with the paragraph tilted with the hydraulic design in this chapter of the UFC. That every responsible effort must be made with the control of the hydraulic surge of the shock within the acceptable limits, designing the piping system rather than using surge suppressors. Surge suppressors are strictly last resort solution and require that the approval of Severus headquarters prior to design into a system. For all aircraft direct fueling and hydrant system design, the loop pressure control valve is critical in preventing excessive hydraulic shock. Using the following design criteria with the table 9.1 for the piping design pressure. For all complex piping system main headers, several laterals, and mobile equipment employ computer modeling techniques to determine the surge suppression that's required to conduct a run at a steady flow of the condition to establish system flow rates for the scenario being modeled. After the conducted transit surge analysis, imposing the worst case operation consistent conditions of the system for the hydrant system, incorporate the use of the back pressure control valve to simulate the valves of the active modulating valve. If acceptable peak pressures are extended to discuss the results. Service headquarters fuels engineers review the parameters used to consider alternatives. If this constellation produces no workable solution, perform a second surge analysis to the model using the surge suppressor in the system. This analysis must indicate the damaging peak pressures that are not exceeded. Do not use a manual surge calculation except as found under because they do not account for the dampening effects of the system yielded over the conservative results. Most systems designed in accordance with the manual would have ANSI class 150 flanges the maximum allowable operation pressure seen in table 9.1. Design the system such as the total pressure, including the surge pump shutoff pressures, the thermal fuel expansion effects, the static pressure in any part of the system never exceeds the maximum allowable operation pressure. Other equipment items such as tank trucks, aircraft fuel tanks, shipping fuel tanks, which may be damaged and shock pressure may require lower maximum surge pressure. Assume the near instantaneously shut off by the aircraft in the design of the aircraft the hydrant system. Do not use manual calculation instead of computer modeling when the system surge pressure is crucial. The piping system is complex. However, the simple piping system that operates under 80 psi, the manual calculations contained with the Appendix B can be used to association if surge will be a problem. Table 9 allowable pressure tables for the ANSI class 150 flange joints, maximum allowable design pressure maximum hydraulic static pressure, minimum hydraulic static pressure, maximum allowable operation pressure, maximum allowable surge pressure. All pressure values are taken by the ANSI ASME B16.5 1996, ANSI ASME B16 4796, ANSI ASME B31 1999 at 100 degrees Fahrenheit. Valves are presented with the information only with confirmed actual valves with the ANSI AMSE BIC 615 655 last edition based on the actual temperature, bolting, the gasket materials, etc. For other materials in ASNI, ASME, BX16.5, and B31.3, the hydrostatic test pressure with maximum allowable operating pressure will be lower than indicated the ASI, ASME, B31.3. 9.3 above ground piping. Support above ground piping so that the bottom of the pipe is minimal for the 8 inches above the ground surface. The higher is required with the service valve and equipment. The area subject to flooding of the greater clearance that may be desirable at the intersection with the roadway, all enough for the clearance with the passage of the tank truck and cranes, similar heavy vehicles in areas subject to the systematic activity provided with the piping configuration support in accordance with the systematic design criteria within the UFC 331004. Refer to the UFC 3130 series. The consideration of extremely cold climate, wherever possible, arranging piping in parallel groups to facilitate multiple use for the supports, minimize the amount of trenching, underground piping, and to minimize the number of pipe styles needed. Considerable constructability, maintenance, and spacing of the piping, and generally use of the rule of thumb. Provide spacing between the piping that allows the minimum clearance of 3 inches between the adjacent flanges. In certain situations, such as piping, trenching, other restrictive location, it may be necessary to reduce the spacing a minimum of 12 inches or one pipe diameter, between which, if it's greater, which should be still maintained between the pipe walls. 931. Identifying piping in accordance with the Chapter 2 of the UFC, in addition with the marking fuel lines and heading fuel pioneer valves and mark valve open or enclosed position. 3.2 pipe support. Resting pipe on support, both insulated and uninsulated. Steel shoe welded to the bottom of the pipe. Leave the shoe free at the bottom of the support and construct the portion of the pipe supports the contact with the ground of the concrete. Facility plate 020 shows the design of typical slide guide pipe support. Ensure the support material with the size same as the pipe material. Other support configurations are acceptable, provided that the support design containing the rollers do not allow the movements of the pipe at the metal surface and does not include the hangers, design pipe, and supports to meet the applicable requirements of the ASNI ASME B31.3, ASNI ASME B31.4. B933 arrangement. Arrange pipes to provide with the fuel expansion contraction caused by the change in the ambient temperature. Whenever possible, accommodate the expansion with the contraction and change the direction of the pipe running. Offsets the loops and the bends with the expansion loops of the offsets off the non-possible flexible ball joint offset. Providing slide pipe that supports other method of maintaining alignment on each side of the expansion joint. Do not use the expansion device with pulling packs, slip joints, friction fits, or other non-fire resistant arrangements. Use the ball type offset joints to accommodate the possible settlement with a heavy structure such as storage tanks. If piping design cannot be provided with enough flexibility, design expansion bends, loops, and offsets with the stress limitations in accordance with the ANSI ASME B31.3 and ASNI ASME B31.4. Thermal expansion of the pipe should also be calculated based on the pipe being empty to include the consideration for the pipe being installed or drained. 934 anchors. Anchors above ground piping. The key points of slow expansion will occur to be the desired direction. Anchors and guides may be used as also required to control the movement of the long run straight pipe near the connection with the fixed equipment such as the pump or the filter. See the facility plate 021. Space anchors to provide with the maximum amount of straight runs for the piping expansion points. The anchors in general place the anchors at all points of the system where only minimum piping movement can be tolerated, such as a branch connection and equipment connection. Key locations of the pump house or other building manifolds to change the direction and is not used for the expansion joints at points where the pipe size drastically reduces related to the adjacent piping. At all terminal points, limit the use of anchors in situations described above. When an anchor is welded directly to the pipe, ensure the anchor material is compatible with the pipe material. 935 thermal relief valve. The coefficient expansion of the liquid petroleum in the range of 35 degrees to 60 degrees API at 60 degrees Fahrenheit is 0.5 10,000 gallons per degree of Fahrenheit. The total volume generated in most cases is very small. This pressure increase the resulting expansion can equate to as much as 75 psi at the average degree. Provided the fuel temperature is not relieved for the reason of the provided in any section of the pipe that has potential to be isolated or by shut-off valve or other means of thermal relief valve to relieve the isolated isolated piping section. Provide a thermal relief valve in the internal cavity of the valve there where the pressure is trapped when the valve is closed in the position. Double block bleeding plug valves, for example. Thermal relief valve should match the material of the piping, which is installed with the provided with valves used with relief and thermal expansion with not less than 3/4 of an inch nominal pipe size. They should be provided with the isolation ball valves with the removable handles on the inlet and outlet. The seat pressure of the relief valve will vary, but considered with the set of the pressure of about 10% above the dead end head pressure of the pump. This should keep the valve with the opening during the normal fuel operations. Ensure the seat at set point with the design limitations of the piping. Do not provide with the thermal relief piping when the site flows indicators. Thermal relief valve should never be discharged with the drop of the storm water drain. The ideal with the relief valve this should discharge the header with which is piped directly to the atmospheric source, such as the storage tank, the product, recovery tank. Often the periodic alternative is to configure the relief valve in a cascading system where each of the relief valve, bypass, shuttle valve, and the isolating pipe in the section discharge back into the main product piping. The excess volume may pass through the two or more relief valves, finally making its way back to the atmospheric source. Caution must be taken to ensure the relief valve have the capacity to handle the additive relief flow the system creates, and the critical relief pressure does not exceed the system maximal allowable operation pressure. In cascading a system, considerable use balance and type of the relief valve, the balanced heat type. Relief valves limit pressure building up the created with the cascading system pressure. The balanced type of the relief valves relief at the point independent of the downstream pressure. In some cases, a small atmospheric tank may be needed to place the proper relief of the piping system. That may cause a system component that has the lower maximum allowable pressure for the rest of the system in a remote location where the cascading system will not work, and the equipment of the tank of the self-checking high-level alarms containing the and see the facility plates 023, 024, 025, and 026. Underground piping provided with underground piping which passes through under public roadways and railroad tracks in accordance with the Department of Transportation Regulation, Title 49 CFR Part 195, API RP 1102, and for the Chapter 2 of the UFC for the corrosion protection for the environment. Protection before installing underground pipes. Review all the federal, state, and local regulations. Double wall pipe leak detection, corrosion protection requirements. 941 depth of criteria. Using the following criteria for the depth of the cover over the buried fuel pipelines. Locate the top of the lines at minimum 3 feet, except less of the cover permissible occasional stretch with the overriding conditions existing, such as the need to pass over the large culvert beneath the drainage ditch. Is such location been able to build sufficient slack into the line to allow the vertical lateral movement down due to the frost heave, and refer to the UFC012 series with additional guidance protective measures such as insulation reinforced concrete slabs with the pipe may also be required if the depth is less than the required under the paragraph B below. Subject to the paragraph 8 is to provide minimum depth in accordance with the Title 49 CFR Part 195, the federal, state, and local regulations under the roadway shoulders. The roadways provided with the minimum depth of 4 feet. 942 parallel and crossing pipes provided with minimum clearance of 12 inches between the outer wall of any of the buried petroleum oil lubricant pipes, extremely for any of the underground structures, including other than an underground pipe. Where pipelines cross the minimum clearance above 12 inches, it cannot be achieved provided with an insulation mat between the pipes and centered vertically on the point of intersection. Insulation mat should be constructed of the narrow iron ball tie rubber and shall be at least 36 inches by 36 inches by 1/8 inch thick, providing a test station with the 2 test seat leads with each pipe. See the UFC 35702029. Electrical engineering cathode protection for more information. Where the government-owned pipe cross area approximately less than 150 feet, contact owner of the non-government pipe for the coordination to prevent mitigating cathodic protection interference. In areas with multiple utilities are routed with the same area of the utility corridor, make sure the electrical communication ducts and conduits are kept with the minimum of 36 inches from all the other underground utilities, especially for fuel system high temperature water pipes. For the NSI, IEE, C2, NSI, ASME B31-4, Title 49 CFR Part 195 for the additional requirements for the pipes. The concrete trenches provide a minimal clearance of 6 inches between the flange and trench walls between the adjacent flange. If there is no flange, provided with a minimum clearance of 12 inches, one pipe diameter based on the largest pipe, whichever is greater between the pipe and the trench wall between the adjacent pipes within the concrete trench. 943 casing sleeve. Use steel casing sleeves only when they are crossing where sleeves are required by authorities having jurisdiction, where it necessary to bore under the roadway or railroad tracks to avoid interference with the traffic. Where boring is most economically, construction method with planning construction and operation trench crossing, considering economics, installing spare casing sleeves and eliminating evacuation of the future fuel lines, ensuring the design of the isolation for the fuel carrying pipes at the contact with the casing pipes. Require a seal annular space at each of the end of the casing, including a vent on the higher end of each of the casing. Locate the crossing in the minimum depth of 36 inches beneath the bottom of the drainage ditch. This is the depth that cannot be obtained with installed above the 9.0 contact the casing of the pipe. The 6 inches that can reinforce concrete slab adequate length with the protect of the casing of the pipe from damaged equipment such as ditch graders and mowers. Refer to the API RP 1102 additional information. 944 line markers except where prohibited. National security consideration. Install line markers are over the each buried line. Allow the maintenance provisions in accordance with the Title 49 CFR Part 195. 945 warning tapes. Provide buried warning tape for all underground pipelines as required by the appropriate guide specification. 946 double wall piping. Provide double wall piping ground vehicle fuel facility. Other applications do not use double wall piping unless required by the state or local regulations. Approved with the service headquarters approved to use the double wall pipe must be obtained with the programming leveling at 35% design level. 947 single wall pipe leak detection system for all single wall buried pipe not be used in the aircraft direct fueling system considered provided in leak detection system approved by the service headquarters. Alright, 9471 leaking detection of aircraft direct fueling system for the aircraft directing fuel system provided with automatic leak detection system approved with the service headquarters to test all the buried portions of the piping system. Automatic leak detection system measure the changes in either the volume or the pressure of the fuel. Fixed pipe system while accounting for the variation in the ambient temperature of the pressure type shall work with the measuring of the time rate of the change of the line of the pressure at two differential pressures. The volume time shall work with the measuring of the amount of fuel required to maintain the constant pressure of the line. Also two different pressures. The system shall have a sufficient sensitivity to detect leaks at least 0.4 thousandths % of the line, 0.4 thousandths for the line volume. The probability detection 95% of the probability of the false alarm 5%. All leak detection shall be third party certified. 9.5 underwater piping. To receive the fuel for the offshore moorings, provided one more of the underwater pipings from the shore facility to the mooring, limiting the design of these systems so that the engineers with the type of experience coordinate with the offshore pipeline system of the NFEC Ocean Construction Division. NF1 951 special arrangement. At the morning of the end of each of the pipeline, provide a length of submarine fuel hose equal to 2.5 times the depth of the high water at the pipe. At the end of the hose provided with the flange removable section of the hose 10 foot long. At the free end of the hose provided with the steel valve with the marker buoy attached to the cable and the chain which has the sufficient strength and suitable fittings to the vessel of lifting the hose of the valve abroad. 952 layout the multiple fuel lines connection so that the correspondence to the layout of ship discharge manifold. 953 unique consideration the pipe design consideration fuel characteristics that may be affected with the seawater temperature, particularly in cold water fuel for diesel fuel, aviation turbine fuel, and other light fuels. Small individual lines are preferably as follows: minimum nominal pipe size of the 6 inches for the transfer of fuels exceeding 3,000 gallons per minute. Use the 12-inch or 16-inch pipe diameter pipe instead of the pipe larger than 16 inches of the diameter. Consider using two smaller diameter pipes. An access uploading location is close to the water entry practical, provided with a double block and bleed valve. The manually operated check valve bypass would allow the reversal of the flow required, provided depending on the means of the communication between the vessel and the offshore berth and the shore facilities. 954 the corrosion protection warp wrap coat cathodically protect underwater pipelines in accordance with Chapter 2 of the Unified Facility Criteria. Depth of burial. Provided sufficient burial depth of the underwater pipelines to prevent damage for the dredging of the waterway. The ship anchors the trowels and the screwing action of the current would specifically ensure the depth that conforms with the requirements of Title 49 CFR Part 195. Where the lines cross shipping channels, the anchorage is ensure the top of the pipe is at least 12 feet below the theoretical present of the planned feature bottom elevation, whichever is deeper. Recommended backfill is such an area of 2 feet of gravel directly over the pipe, following the stones weighing 50 to 60 pounds up to the bottom of the elevation. 956 pipe thickness and weights. Provided sufficient wall thickness to keep the stress due to the maximum operation pressure of the other design loads within the design limit, including the full consideration of stress, and stress may occur within the length of the pipe. It is common practice to use heavier wall pipe for the water crossing of more than 200 feet for the bank of the bank and normal water level. They affords greater stiffness and resistance to buckling during the handling of the assembled cross piping, which requires less of the weighting of material to obtain the necessary negative buoyancy to keep it in line with the place where the empty and containing the light product. Reinforced sprayed on concrete is an acceptable weighting material. Hydrostatically tested assembled cross piping before placing, unless cross piping is too large for prior assembly in one segment. In this case, separate tests each segment is described. 9.6 piping materials. 961 non-aviation system. Using carbon steel pipe material, the internal terminal pipelines, regardless of the product or all portions of non-aviation turbine fuel system, the FRP may be used for the underground pipe, non-in-ground concrete trenches, the in-ground vehicle fueling to the system. Facilities FRP is not used in the aviation turbine fuel system application. For the appropriate service guide, specification includes necessary requirements to see facility plate 022. 962 aviation system. New system shall use the stainless steel issuing pipe with the interior coated with carbon steel may be used and approved with the service headquarters for the piping downstream of the last issue of the filter separated. Turn of the pipe shall interior coated with the carbon steel, giving special consideration to pressure rating with the bolt of the pipe with the fittings to ensure the adequacy accommodated with the surge pressure. See facility plate 022 for the piping operations. 9.7 welding criteria. They ensure the contact required the welding inspection in accordance with the appropriate guide specifications and standards. Design proper welding done in accordance with the guide specifications will prevent loose adhere slag on the inside of the pipeline. Use 100% of the radiographed welded joints meeting of the standard of the cervic silical surface contained with the ANSI ASME B31 3 for piping downstream of the pipe of the hydrant system. For all the other underground steel pipes, use the 100% radiographed welded joints meeting the requirements of ANSI ASME B31-3 for the pipe connections. For the steel pipe systems used with welded neck forged flange with raised faces that have been modified spiral serrated gasket surface finishes. Do not use cast iron flanges. Do not use groove pipe, the type of couplings. Similar fittings in permanent fixed piping system. Do not directly bury the flange valves and the mechanical couplings, threaded fittings, or any of the mechanical equipment. If they must be used in an underground system, enclose them in an accessible pit. Use the welded connection for the joining steel pipe. They use the flange connections for the joint pipe to equipment. They use the threaded connection only where the unavoidable, such as the differential pressure, gauge pressures, numbers, and fuel sample points. Unusable carbon steel bolts and studs and nuts, and the carbon steel flanges use stainless steel bolt studs and nuts. For the stainless steel flanges, stainless steel bolts may be used for the carbon steel flanges and corrosive environment. Select the stainless steel bolt studs and nuts based on the seizing of the elongation coordinated with the bolt strength with the force needed to compress selected gaskets. In the location where severe corrosion typically saw air is a suspectable, use flange and bolt seals filled with grease preservative is required to prevent the control corrosion. In steel piping system, use the socket welded joints on a 2-inch diameter nominal size of the smaller pipe. Make branch connection with the butt weld tees, except for where the branches at least 2 pipe sizes and smaller than running, in which the case of the branch connection can be made with a forged or semi-less branch outlet fitting, which is designed in such a way that the connection can be radiographed. Do not use wrinkle bends with mitered bends of the change of the direction. For example, except for units in control of the tubing and the couplings, do not use threaded joints in stainless steel system. Socket welded stainless steel drain, vent, or pressure relief valves lines 2 inches in diameter or less if above ground, and flanges may be used. Join the glass FRP piping by the bell and spigot joins sealed with adhesive except for the FRP flange for the connections to flange equipment such as the pumps and valves. Ensure that no loading can be transferred from the steel piping to the FRP piping. Connect all the dissimilar metals with the isolation flange. 9.9 Interior pipe coatings. To protect the aviation fuel quality, extend life with the piping, minimize bare carbon steel piping except for the internal terminal pipeline which comes into contact with the aviation turbine, especially downstream initial filtration equipment. Maximize the use of internal coated pipe. This is not intended to allow the use of the inline carbon steel piping as the substitute of the areas required for the non-ferrous piping. Apply the other paragraphs other than chapter of material selection. Interior piping coating is not required for the non-aviation pipers except for the carbon steel piping with lower 36 inches of the above ground vertical storage tank at the ballast lines and piers. 910 exterior pipe coatings protect the exterior surface of the underground steel piping system with continuous extruded polyurethane coating the system with the fusion of the bonding epoxy coated welded joints system compatible with the piping codes protect the exterior surface of all above ground coated carbon steel piping system containing in accordance with the applicable surface requirements. Exterior surface of the pipe shall be prepared with abrasive blasting and clean prior to the coating of the application. Coating underwater piping with the same material used for the underground piping. In addition, with the coating underwater piping, the reinforced sprayed on the concrete, similar type of the material with the pipe stabilization to provide navigable buoyancy, and with the pipe when the pipeline is empty. 911 sampling facilities provided with communication and sample filling of each section of the fuel transfer piping system installed. The sample testing connection, receiving point, tank outlets, and outlet size of filter separators. All fuel dispensing points between the isolation valves and so with the remaining fuel in each portion of the fuel transfer pipeline could be sampled. Where possible, installing sample connection to the vertical runs provided with a 1/4 inch diameter sample point with a probe ball valve and a quick disconnect with the dust cap. Chapter 10 Alternate POLs, or petroleum oil petroleum oil lubricant facilities. Chapter 10 1 Introduction.